Good morning, everybody that's watching live. The chat feature should be open and on today. If you guys want to talk to each other for a second, otherwise we'll get started in about a minute here. If you have any questions, type them in the chat over there. Okay, I'm going to send you guys something. Give it just a second here. Some of you I know don't have your warm-up packet with you because I chatted with some of you during the other class yesterday. Here is the new warm-up. If you download this file that I just sent to you all, desktop, and give it just a second, it's sending. Just a second, it's still thinking about sending. There we go. All right, there it's sent. If you would open that up and go to section number 3, and obviously this is going to take a minute, so I'll give you a minute to get there. If you go to section number 3, which starts on page 38. So now we're back in a no calculator section. If you do those first 3 problems, the first one is what value of z satisfies the equation above? What value of z satisfies the equation above? Ready, set, go. And don't forget, you can't, for those of you just joining us, because our numbers just about doubled, the chat feature should be on for you to see today. So if you got questions, type over in that chat part. Otherwise, I sent you that on Remind. Download those first three and ready, set, go. Nobody's typing in the chat. Can you guys hear me? Am I on? Okay, whew. Good, one person. All right, so again, if you're just joining us, I sent you an SAT packet. Go to page 38. That's the start of section 3, and do those first 3 in there. Hey, good morning. What's that?
I woke up 5 minutes.
5 minutes ago?
Mhm.
You want some breakfast?
Oh, yeah.
Cereal. Can I give you a special treat this morning?
What do you mean? So these have the lowest numbers, and this one has the highest. I want to choose from the highest.
Okay. Very good.
The highest won't run out. The highest will be the least amount of number that will run out.
Let's go get you a bowl.
Oh, Dad, don't forget to shut.
Oh, yeah, otherwise the cat will eat it all.
How can the cat eat it all? It can't open the boxes.
All right. Are we... Ooh, message retracted. Oh, I could put you guys in timeout. Ooh, that's fun. All right. You guys ready for the answers? I thought you guys would want to talk to each other. Or are you just looking forward to spring break and getting it over with? No comment. Nothing. All right, fine. Then let's go to the answers. Oh, let's do. Okay, so go over to the message feature and type in the answer you got for part A or for number 1. Type in the answer for number 1. Okay. And you guys can use the chat feature over there. You don't have to use the remind anymore. I figured out how to open it up. The issue that we had was some of you established your whatever Google account you're using. You established it when you were middle school, so you did check the under 13 box. So I had to set it up a little bit different, but I figured it out. All right, here's the solution. Which I'll put in the box over here. The right answer is be like boy, but it's coming. Hopefully. All right, same thing for number 2. Oh, it doesn't let you use it if you're aligned with the school account. Sorry, Will. Shh, don't tell anybody. You'll have to get your own Google account. Good thing they're free. So put your answer in for number 2. The correct answer for that one is got some variety on that one, but the correct answer is C for number 2. If you put part A, you forgot the initial payment with that. And let's do the same thing for number 3. Put your answer in A, B, C, or D. Got an A. I feel so sad you guys can't go to the board anymore and do this. Like, for number 3, the correct answer is be like boy. And here is the reason why. Since you're in class 2, I'll send you the oops, wrong button. Here's the link to the answer keys for these as well. The reason you want that is it's got the full explanation of each one. Like if you missed it, then you can see like what you what the correct answer is. But let's take any homework questions you have. So take a second. If you got any of those we went through last time. And again, I'll wait. Again, it's kind of weird. It's 15 seconds behind. Okay, let's go through. I'm gonna fix this Schoology issue real quick. All right, can we do number 4? Yeah, we can do number 4. Number 2, number 4. Let's go through those real quick. So let me just bring it up real quick. I'm looking for it. Nope. All right, let's go to number 2 first, because number 4's got a little bit of a trick to it. 1/4. Okay, so there's number 2. We got to do transformations first, which I'll just do verbally with you guys. Okay, so this is our inner part of our function. So x plus 4 is going to move it 4 to the left. Good job. This is again on the outside. It's not on the inside. So multiplying by 1/4 is a vertical compression or a vertical shrink by a factor of 1/4. And then -3 is going to translate it 3 units down. All right, so I'll give you the point. We'll do the points, then I assume you guys can graph it once you've got the points down. 1/4 times 2 to the power of x plus 4 minus 3. All right, so let's go with our original 5, our key 5 points. All right, so what's going to happen to our x values? That's inside of our function. What's happening inside of our function is we have 4 units to the left. Milo. Pause for my dog to viciously defend us all here. All right, for Milo. Shh. Milo. Killer. He's such a killer. Here, I'll just put him on the outside real quick. Hopefully nobody else goes by. All right, so the only thing that's going to happen to our x values is we shifted them 4 to the left. Good job, 4 to the left. So -2, 4 to the left takes it to -6. Notice again, as I was talking about last time, -6, when you substitute that in, what you're going to raise 2 to the power of is still -2. Okay. Next, shift this 4 to the left, 4 to the left, 4 to the left, 4 to the left. Okay, now we get a little bit harder. We got to vertically compress it by a factor of 4, and then we got to translate it 3 down. Which order do we do it in? Of course, we do the compression first, and then we do the translation second, because order of operation, if we substituted a value in, we do this, we do this, we do this, we do that. So we're going to take these all and divide them by 4. Now, this is kind of tough. 1/4 divided by 4, or 1/4 multiplied by 1/4 gives us 1/16 minus 3. Okay, 1/16 minus 3. Well, how many 16ths are in 3? Well, that's 48. Yeah, can you give me just a second, honey? So that equals 40 negative 47 over 16.
I give you a second.
Okay. Yes, my honey, what's up?
My show keeps on saying words and I don't like it.
You don't like it? You want it off?
I don't want the words.
Oops.
That's the thing.
Oh, that's weird. There you go. Fixed. Okay, sorry about that. Next one, 1/2 divided by 4 is 1/8. 1/8 minus 3. Well, issue with that is we got to convert it again to a common denominator. So 1/8 minus, well, common denominator is 24 over 8, which is equal to 23 over 8. Okay, now we get a little bit easier for a second. 1. Vertically compress it. In other words, make that distance between it and the x-axis 1/4 as large. So 1/4 times 1 is 1/4. 1/4 minus 3 is 2 3/4. What's negative 2 3/4? What's that as a mixed number? 2 3/4 gives us negative 11 over 8. Now it's speaking. Oh. Speaking Spanish. There you go. Sorry about that. 2 times 1/4 is 1/2. Minus 3 is minus 2.5. What's minus 2.5? That's minus 5 over 2. Last one's the easiest one. Luckily, we get lucky for the last one. 1/4 times 4 is 1. 1 minus 3 takes us to -2. And I will assume you guys can graph those points once you've got it. Stop and check up questions on that.
It just made some voices of what they were doing. Dad, it's going to make some voices.
It's okay. It sounds normal.
No. I mean, like, there's a difference in them talking, and it says what they do.
Sounds normal to me, girl. But honey, I got to teach right now. I'm working. Number 4. Number 4's got a little twist to it. Number 4. On 4, we had, let me go back to it. Number 4, we had y is equal to 1/3 times 4, not 2, to the x minus 2 plus 1. How do we convert 4 into some power of 2? How do we convert 4 into some power of 2? Listen. Listen, you're gonna have to deal with it for a little while. I gotta do class, okay? All right, how do we do that? Well, that's equal to 2 squared. So we're going to substitute that back in. So y is equal to 1/3 times 2 squared to the power of x minus 2 plus 1. What do we do with the power to a power? Right, we multiply them. And that's how we get a horizontal shift, a horizontal stretch or compress with these, is we have to have something that raises it to a power. All right, so then let's talk about what the translations are. Minus 2 moves it 2 to the right. Now, this is on the inside, so multiplying by 2, remember, anything on the inside before the action of the function. So it's not going to be a horizontal stretch. It's going to be a horizontal compression by a factor of 2. Now we're on the outside. These are after you'd raise it to the power of 2. So 2 units right, horizontal compression by a factor of 2. Horizontal or vertical compression by a factor of 1/3, and then translated 1 unit up. So translated 2 to the right, 1 up. Horizontal compression by a factor of 1/2, vertical compression by a factor of 1/3. Stop and check up. Questions on that real quick? All right. Could you not keep the 4? Yeah, but then it's a different type of problem. Then we're not basing it off of the same function. I mean, that'd be like basing it off of x squared instead of just x squared for your transformation. And the directions in the assignment were to base it off of 2 to the x, which is why I wanted to do that. But let's find the transformation here. 1/3, 2 to the 2, x minus 2 plus 1. Now this is going to be, again, we go back to order of operation. What do we do first? So let's first look at our parent function, -2, -1, 0, 1, and 2. 1/4, 1/2, 1, 2, and 4. All right. First thing, if we substituted a value into this, what would we do first? Would we minus 2 or would we multiply by 2? Yeah, we would minus 2 first, and then we'd multiply by 2. So, okay, so the first thing we're going to do is we're going to minus 2 from it, and then we're going to we're going to, said it wrong. We're going to translate it 2 to the right. Then we're going to horizontally compress it. We're going to take that distance between that and the y-axis and cut that in half. So first thing, we're going to move it 2 to the, we're going to translate it 2 to the left. Sorry, 2 to the right, 2 to the right. So that takes this to 0. Now, what am I thinking here? X minus 2. Yeah, 2 to the right. So we translate in, substitute in 2 to the right. So -2. If we move it 2 to the right, that's 0. Then if we take 0 and compress it, well, it's still at 0. So 0 it is. Yeah, 2 to the right, and then horizontally compress it. Okay. Yep. All right. Now we go to 1, -1. 2 to the right takes it to where? 2 to the right takes it to +1. Then compress it by a factor of 2. That takes it to 1/2. 0, 2 to the right takes it to 2. Horizontally compress it by a factor of 2, takes it to 1. 1, take a 2 to the right is 3. Compress that distance by half. That takes it to 3/2. And 2, 2 to the right takes it to 4. Compress it by half, takes it to 2. And notice we had that same thing last time where we had those stair steps where the intervals were the same. That's a good way to check to make sure everything we're doing is okay. Now we get in. This is going to be tough. Woo! We're going to vertically compress it by a factor of 3 and then add 1 to it. We're going to vertically compress it by a factor of 3 and then add 1 to it. So 1/4 vertically compressed by a factor of 3 takes it to 1/12. 1/12 plus 1 is 13/12. Whew. 1/2 compress it by a factor of 3, or in other words, multiply by 1/3 takes us to 1/6. 1/6 plus 1 is 7/6. 1 vertically compress it by a factor of 3 is 1/3. 1/3 plus 1 is 4/3. 2 times 1/3 is 2/3 plus 1 is 5/3. And 4 times 1/3 is 4/3. 4/3 plus 1 is 7/3. Now, should these be a stair step? No, because it's not a linear equation. It's an exponential equation. So eventually it starts to grow by more. So notice the growth is small, a little bit bigger, much bigger. And that's okay. All right, let's go on and talk about our new lesson today. We're going to figure out learning target 6.4, and then we're going to talk about 6.5. 6.5 is the exact same thing, but now we're doing it with radical functions. Radical function, we'll start out with a parent of y equals the square root of x. We'll get our 5 key points. Oh, sorry, 4 key points on this one. 4 key points on this one. So real quick, fill in your y values and then make a graph of this bad boy. Fill in your y values and then make a graph of this bad boy. Sorry, I had to check on my kids for a sec, make sure they're still alive. All right, what are our values? Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Why did I use 4 there? Because it's got a nice perfect square. Square root of 9 is 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. All right, 0, 0, 1, 1, 4, 2, 9, 3. There's what our graph looks like. And this is our parent function. Question, why did I not substitute a number in that was negative for x? Right, because it wouldn't be in the domain of the function. So let's get that down. Let's go domain and range. Domain, of course, from the very start of the year, the values we could substitute in for x and get an answer out. Range, the values we are going to get out for y. This one's, as I mentioned at the start of the year, polynomials, they were always negative infinity to negative infinity, negative infinity to negative infinity. All right, domain, what's the smallest value we can substitute in for x and actually get an answer out? That's right, it's 0. Then will this continue to go up? Yeah, we can substitute any value in larger than that. The range, what's the smallest output we can get? Again, 0. What's the largest we can get? Infinity. So kind of odd. A radical function has a parent that is y equals square root of x. Graph looks like that. Definitely not as steep as an exponential. You notice it really starts to level off. And then the domain and the range. Stop and check up. Questions on that real quick? The range is 0 to infinity because we start at 0. That's the smallest value we can get for our output. Remember, range is talking about the y values we can get. That's the smallest value we have for our output. Any others? Other questions? All right. So let's do a couple transformations with this, and then let's solve some equations with this. We got to get back to the glory days of algebra. So let's look at example number 1 here. If our parent function f of x is equal to the square root of x, and g of x, our transform function, is equal to 3 square to the quantity x minus 2 plus 4. What are the transformations that take us from here to here? And then we'll graph that bad boy. And by now, you've gotten very used to inside the function is anything before you take the action of the function, and the action of this function is the square root of x. So this would be our inside. Those, of course, affect x values. These are outside. They affect the y values. So real quick, verbally describe the transformations. Verbally describe those transformations. Ready, set, go. Vertical stretch by a factor of 3 and 4 units to 4 units up. Okay, now let's go to kind of an honors level question. What's then the domain and range of this function? The domain and range, if we move everything 2 to the right, that's going to move our domain 2 to the right. So instead of starting at 0, it's going to start at 2, right? Because if you substitute in 1 now, you get an imaginary number. So our domain for this is now going to be 2 to infinity. Our range, okay, we vertically stretch it by a factor of 3. If we stretch out 0, that's still at 0. If we stretch out infinity, that's still an infinity. But if we move everything up 4, our range won't start at 0 anymore. It'll start at 4, right? So 4 to infinity. All right, then part C. Let's at least identify where those key points go to, and then I will let you guys make the graph of that bad boy. So x squared of x, 0, 1, 4, 9, and x, 3 square roots of x minus 2 plus 4. All right, we shift all of these 2 to the right. So instead of at 0, we're at 2. Instead of at 1, we're at 3. Instead of at 4, we're at 6. Instead of at 9, we're at 11. Notice that's shifting everything 2 to the right. You shift all of them 2 to the right because it's a inside where we have x minus 2, so that shifts everything to the right 2. Shifting it all to the right 2 adds 2 to the x values. All right, then we had our y value, 0, 1, 2, 3. We're going to vertically stretch them by a factor of 3 and then add 4. Why do we do that first? Is because if we substitute in a value, notice we're following order of operation. And notice if you substitute in 2, you're going to do 2 minus 2, so you're still taking the square root of 0. All right, so where does that end up? We take 0, multiply it by 3, we get 0. Plus 4, we get 4. 1, multiply it by 3, we get 3. Plus 4, we get 7. 2 times 3 is 6. 6 plus 4 is 10. And 3 times 3 is 9. 9 plus 4 is 13. And I will let you guys graph that bad boy. I know by this point you can. Okay, so we're going to get a couple parts of the homework tonight just to give you something to do over spring break. I know with everything happening, it's hard to even get drugs now, so something to do over break. But part 1, and we're going to call this Learning Target 6.4, 6.5 assignment. Part 1, I'm actually going to go to your book. It's on page 256. 256. And I want you to do it in this order. I would like you to do 19, 20, 23, then go back and do 3 through 8. 3 through 8 are matching, so those are pretty easy. 9 and then 13. All right, and I'll show that for you real quick. And then let's do the second part of this here lesson. Get your money's worth out of today. Learning Target 6.5 is about solving radical equations. And we get a new vocab term in this, and it's called extraneous solutions. What's an extraneous solution? Extraneous solution is a solution generated by algebra raising the degree of an equation that does not solve the original problem. That does does not solve the original problem. All right, so let's take a look at an example of solving these bad boys. X plus 1 is equal to the square root of 7x plus 15. All right, so how do we solve this? Well, we look at this. We we got an x plus 1 over here. We got this over here. So you got to think, like, how do we undo that? Like, there's no way for us to take something inside the square root without squaring it. We can't take stuff inside any terms inside the square root unless they're being multiplied. So the only option we have is the first step on this is we want to isolate the square root. We want to isolate that square root. What's that going to do? Then we're going to square both sides, because if we square the square root, what's going to happen? When we square the square root, that's going to take away the square root because it undoes it. Now here, we'll just take a look. So we get x plus 1 quantity is equal to, if we square that, we get 7x plus 15. Notice now we had a degree 1 equation. Now we have a degree 2 equation. What does that mean? It's going to generate those extraneous solutions. So we're going to probably get 2 answers to this one, but we'll want to go back and check, like, what do we need from that? All right, so what do we get? X plus 1 quantity squared. Well, we got to combine some like terms, so we have to FOIL this. That gives us x squared plus 2x plus 1 is equal to 7x plus 15. We're really good at solving quadratics that are equal to what? Equal to 0. So we're going to minus 7x from both sides. We're going to minus 15 from both sides. So we get x squared. What's that going to be? Minus 5x minus 14 is equal to 0. And darn, it's snowing pretty good right now. At least in my house, snowing pretty good. All right, then this is when we go back to the quadratics unit. Like, what can we do now? We could factor, use quadratic formula, complete square. All right, so what do we get from that? Does that factor? Yep, it does. X minus 7, x plus 2 is equal to 0. We use the zero product property. X equals 7 or negative 2. Now we got to go back because we raised the degree of that, and that should be the light or the like ding 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 that goes off in your head. Now we got 2 solutions to a degree 1 equation. We got to now go back and say, what do we do about this? Okay, so now we're going to substitute in both values and see which one actually generates a solution. It's a solution if it makes this equation equal. So let's substitute in. So 7 plus 1 is 8. And of course, we want to write off to the here what we're doing. Checking x equals 7, 8. Substitute in 7. We get 7 times 7 is 14. 9 plus 15 is 64. Is that? Yes, it is. Do we have to consider the plus or minus here? No, we do not, because the problem had a square root in it. We didn't introduce the square root into it. Let's check 2. Oh, sorry, negative 2. Negative 2, which you can kind of see already what's going to happen. Negative 2 plus 1, the square root of 7 times negative 2 plus 15. Negative 2 plus 1 is, you see, is this going to return a negative 1 for us? No, it's not. It's going to return 7 times 2. Negative 2 is negative 14 plus 1. So the square root of 1. Negative 1 does not equal 1. So our only solution to this problem is x is equal to 7. All right. Stop and check up. Questions on that? Let's give you one to try. Let's do, and this will be our last example before break. Then you get a week off. Think of that. Then you get a week off. Let's go for, let's go for this one. Let's go for x plus 30 to the 1/2 power is equal to x. X plus 30 to the 1/2 power is equal to x. Give you guys a few minutes to try it. Don't forget, 1/2 power is the exact same thing as square root. Right on. Right on. Ready, set, go. Can there be no solutions? Of course. All right, ready to go through it? Give me 2 seconds. I got to change some Schoology. I'm working on something in Schoology here. All right, let's go through this bad boy real quick, and then let you have a wonderful week off, which is going to feel super weird. But okay, what do we do to both sides first? Well, let's pretend they're just real quick +1 over here. If there's a +1 over here, we gotta isolate this first. Because to square both sides, we gotta isolate that bad boy. So in this problem, we have it isolated. So we'll square both sides. So we get x plus 30 is equal to x squared. Notice now we went from a degree 1 to a degree 2, so we're probably going to generate a superfluous solution, or an extraneous solution. Sorry, extraneous solution. Now we're really good at solving quadratics that are equal to 0. We like to keep the x squared positive, so we're going to minus 30 and minus x, minus 30 minus x from both sides. Does that factor? Yay, it does. X is equal to -5 or 6. Now, let's go back and see which one works. So let's check x equals -5 first. Is that going to work? No, I don't have to go any farther. Is the square root going to return a negative value? No, it's not. So that can't work. Zach asked about is it possible that neither one of them work? Well, let's see. Is this one that there's no solution to? Is it possible to have no solution? Of course it is. All right, 30 plus 6 is 36. Square root of 36 is 6, so this one does have a solution. So our only answer for this one is x equals to the 6. All right, let's give you some problems to work here over the break. And then I'll show you how I want you to turn in homework. Then second part of the assignment's on page 266. I would like you to do 3, 4, 5, 8, 10. The bad news about 8 and 10, the answers are not in the back of the book. And then 35. And that's it for now. I'll put that up real quick. I'll text that out at some point, maybe later today. Because I had a couple like work-related things I got to do today. Hope you all have a great spring break on all of us. Schoology folder. So if you go to your Schoology, click on chapter 6, the chapter we're in right now. Last night's homework is the 6.4 assignment. Please upload your assignment into there. Please upload your assignment into there. And then tonight's assignment is the 6.4, 6.5 book assignment. Take a picture, upload that bad boy into there. And then we will have a learning target quiz next time, just to give you guys some feedback on how you're doing, but we'll do that after spring break. So I'll pause for just a second to see if there's any questions. Just to see if there's any questions either in the chat or on the remind. Jordan, let me go check real quick. I think I copied it to the 6th period or to the 8th period class, but let me check. Jordan, give me just a sec. I thought I copied it. Let me make sure it's copied. Jordan, just seconds, being slow. Jordan, I'm hitting save. Just a sec. I'm working on that. There we go. All right, Jordan, let me go in real quick. Schoology's slow, obviously, over the last few days. Kind of busy. So let's go check and see if I can see it in there now. Yep. Okay, Jordan, it's in there now, so you should be able to see it. Christian Clayhan, same thing. You can see it. Yeah. Sorry, Will. Just take a picture of it and submit it. Yeah, that's probably what we're gonna have to do for homework from now until the end of the year. The homework from 2 days ago is the homework that was due on Monday is 6.2 homework. Send that to me in an email just because I didn't set up a folder for that, and I've already been taking it that way. All right, guys, have a good day. See ya.